Cool. So we don't have daily quiz because yesterday was a dumpster fire. Instead, I would just like really quick show me that you remember how limits and the continuity test work. Is this continuous at -1 and -2? Go! This is just seeing if we remember stuff. Go ahead and talk, work with each other. That's fine.
Okay, so negative 1 must be put in the hole. Because this is a jump one. So it's oh yeah, remove one. That's it. But yeah, so remove it. When it's x equals -2. Because this works, so like the what do you figure out? I definitely understand. What is the same? So you go like negative. Because they're going in the same direction. Okay, so what is it still? Oh, it's the y value. So what's the y? Yeah. Well, it would be nothing because since there's a hole there, it can't approach it. Also, yeah.
I hope that we at least caught that. Said every time you run across a rational expression, factor. Because there's always a chance you can cancel something out. Before I do anything else, I hope we're starting to recognize what these are. I just removed a factor at x equals -1. Always the zero of this. Right there, I know this is removable discontinuity at x is -1. After we do the continuity test stuff, you're not going to have to prove it with the test anymore. You should be able to just see that and know I removed a factor. It's going to have a hole there. Holes, by definition, are a removable discontinuity. I should see a remaining 1 over x plus 2. Well, that's going to divide by 0. This is a rational function. Rational functions create infinite discontinuity at the zeros of those factors. Okay, so we should just start to recognize this. It'll come a lot easier after we do the full review on rational functions, including vertical, horizontal, and oblique asymptotes. But if I was looking in a calculator, I would check f of -1. Try the function of -1. I try to put -1 in and it tells me error. You can't do that. I go to the limit of my function as x gets really close to -1, and it comes out really, really close to 1, like 0.99999, 1.0011, whatever, on both sides. So it's getting really, really close to 1. Now, empty set still does not equal 1, so it still fails. You still fail, pass, fail, and you tell me what kind it is. I know it's removable because there's a hole. I know there's a hole because I removed a factor. Other one. I try the function of -2. It tells me you can't do that. And then I try limit. In this case, as I come at -2 from the left, -2.00000001, negative infinity. As I come at it from the right, -1.999999, positive infinity. Those are not going to the same place. So there is no limit. It does not exist. Now, ironically, ugly equals ugly. So pass, fail, fail. It's still going to be infinite discontinuity because if I were to graph this, different color, orangish, you're going to have a vertical asymptote at -2, horizontal asymptote at 0, and it's going to do one of these numbers with a hole at -1, 1. Okay. We'll get really good at these rational ones later. But for now, can you just plug and chug on the calculator to get that test? Yes? No? Feedback. Okay. Then we move onward. Intermediate value theorem is dumb, but I'm still going to show it to you because it might be one of those random things that you see again on an ACT. In all my classes, because I'm still bitter about it nearly 20 years later, I say I don't want to be the guy who keeps you from money in our exhaustively expensive collegiate system because I never showed you this one thing. And that happened to be the one thing on the ACT that you got wrong. Okay? Y'all know how, right? Mostly juniors, some seniors. Yeah. So you've all at least taken the pre-ACT, right? Unless you transferred in and now you're a junior. Maybe you didn't take it before. Whatever. The way it works, what is it, like 60 questions for the math section? 40? Okay. It's like 75% of it is through Algebra 2. About 20% of it is a grab bag of college algebra PreCalc. And then 5% of it is the back half of PreCalc on through trig and calc. And because it's such a small section of the test, it's just a grab bag of what they're going to use. For me, it was a single summation sign. I just forgot what it meant. Difference between a free ride anywhere versus $25,000 student loan debt. Okay? So I'm going to show you the thing, even though I think it's dumb, because it might be that one thing that shows up on a test that determines your financial credibility. Here's how it works. If I plug in the function of A, and I get a negative number, and I plug in B to get the function of B, now it's a positive number. Well, if this button gets me a negative, and this button gets me a positive, what has to be somewhere between them? 0. The zeros of a function are somewhere between a negative and positive function value. Like that's it. That's the intermediate value theorem. It's kind of dumb, but y'all remember the polynomial root theorems, like Descartes' Law of Sines, and the rational root theorem, and all that kind of stuff? Okay. Oh.
In geometry.
No. Not Law of Sines, S-I-N. Descartes' Law of Sines, S-I-G-N. No? I'm pretty sure you did. We'll review it in polynomials. It's like, go put in a positive x into the polynomial, count how many sign changes there are. Determines how many positive or negative real roots there are. Put in a negative x, count the sign changes, however many sign changes there are, and then it always decreases in pairs. So like there's 4 possible positives, or 2, or 0. It's a standard in Algebra 2. I guarantee you did it, whether you remember it or not. This is one of those. The intermediate value theorem is one of these things that just helps you to narrow down where are the solutions. Okay? Now, if you live in the 21st century, we're going to have a calculator to just look at the freaking screen and narrow down our options. But I still got to show you, because you'll say, well, I've never heard of that, just like you are right now about Descartes. Okay? This thing, determine between which consecutive integers on the given interval the zeros are. So, in this range, where are the zeros? So they want you to plug in -4, -3, -2, -1, 0, 1, 2, 3, 4. Now, I'm not going to do that because I'm going to make my calculator do it for me. Y is, what was it? X squared minus 4x plus 2? Oh, x cubed minus 4x plus 2. Right? Plus 2? Yeah, plus 2. I do the thing. Now, we're specifically talking about between which integers this happens. So I don't need to go monkeying with my table at all. I can just leave it in autofill and, come on, integers. Okay, so my table goes from -5 to 5. It says specifically on the interval from -4 to 4, between which consecutive integers do my zeros lie? Well, I see it goes from negative to positive right here. So I'll say between -3 to -2. I will use parentheses because I'm saying between them, not at them. Y'all remember that? Like, bracket equals, parenthesis doesn't equal. Between means I won't actually equal. And I see it happen again here and again here. So here, between 0 and 1, and between 1 and 2. That's where my zeros will occur. That's the intermediate value theorem. If it goes from negative to positive or positive to negative, somewhere between there is one of the zeros of the function. Okay. Now, where this could be used, as we talk about, standardized testing and that whole national monopoly, could you use this on an ACT to just narrow down choices without actually going through the math? They give you some big nasty equation. You have no idea what it is. And it says, what are the solutions to the function? Throw in table, look for where it goes from negative to positive or positive to negative. Which of A, B, C, D, E is between -3 and -2? Oh, this one. Move on with my life. Okay? Unfortunately, how many of you have already done one of those ACT prep things, like classes or whatever, okay? They're not about, here's content knowledge, is it? It's how to game the system. It's a class on how to take the test, on how to be faster at the test, strategies to just get you through the format of it. And that's incredibly biased and all that kind of stuff and blah, blah, blah. But this is one of those tricks. Is dump it in your calculator. You know what? What if I don't even look at the table? What if I say screw the table? I'm betting the whole lot of you are intelligent enough to just hit graph and it asks between which consecutive integers does this function have zeros? Pretty sure it's between 0 and 1. Do you see why it's kind of a dumb rule, like redundant? Now, this is how we had to do things back in the ancient days, before the advent of the graphing calculator. I am not that old. I used that in high school, okay? Like that exact thing. So, before my time, when they had to chisel and hammer out their polynomials, yeah, they had to actually use intermediate value theorem. Okay? So, don't even bother with part B. Just make sure you have written here what the three were, just so I know that we talked about it. Cross out this whole page. Pretty sure you all got that. I don't even know if I put that in the homework. I might have put 1. Okay? I think you can just look at a screen and tell me between which two things the zero is. So, instead we'll go to end behavior. I was a little alarmed the other day when I started talking about that end behavior chart and kids started saying things like, oh yeah, up and down, down and up. I remember that.
That's actually college.
Okay. So, end behavior is a limit as you approach plus or minus infinity. The limit of this function as x approaches infinity. Now remember, limits, we were saying you'd have to come at it for both sides. Well, you can't really come at positive infinity from in front of infinity because it's not a location, it's an idea. I can still say, the further I go to the right, what are my y's doing? They're going to keep going further and further negative, right? So the limit is negative infinity. As my x's go all the way to the right, my y's go all the way down, I will call that as x approaches infinity, the limit is negative infinity. The limit of my function as x approaches negative infinity. So as my x's go all the way to the left, where are the y's headed? Still negative infinity, right? So the way that I had done it in Algebra 2 is we just treated it like a coordinate. As x's go to infinity, y's go to negative infinity. We just treat it like a coordinate. X's, y's. X's go here, y's go here. Okay? So I've always done it that way to prepare kids for limits. So even if you don't come up to PreCalc, kids will still see a limit on an ACT, and they'll be like, well, x's, y, yeah, it's probably that one. At least give you a shot, right? So that's all end behavior is. As my x's go here, my y's are going where? And sometimes that can be infinity. So, find its end behavior, support the conjecture numerically. Told you this book likes tables. The way that they want you to do this, it's so stupid. They want you to copy down that table and actually find those values by sticking them into your calculator. To show that as the number gets really, really big or really, really small, this is where it's headed. Y'all, here's my polynomial. Negative x to the fourth, 8x third. Negative x to the fourth plus 8x to the third. Frank, you can eat my contempt. Y'all just waiting for it, weren't you? You can eat the darkest part, but no. Plus 6x. Short-term memory is bad because I was hitting the head too much. Minus 80. Okay. If I do this thing, and then I go to my table, and come on, Frank. Switch that back over to ask. Okay. This method is brought to you by Mr. Drake Faroki, a former student of mine who said, so if I want to know when it goes to positive infinity, can I just what is this number? Negative 1 times 10 to the 56th. That's negative 1, 55 zeros. What is that? Insanely negative. That's like halfway to Taiwan. Okay, just keep digging. So I would just say negative infinity. So I can do it on the table, or I can just look at the graph. I don't care. When it says to support the conjecture numerically, I would like you to cross that out and give it a big old bird and say no. Because, that's how you found it. You looked at the graph or you spammed 9s in your calculator and this is what you got. So you're good. Okay? Those two, just right there. Can you write their end behavior as limits?
Can we do it as a coordinate? Or would you rather
As a limit. Yep. As a limit. Like the coordinate thing is what we did in Algebra 2 to prepare us for limits. And randomly, because that's how my bouncing ball works, we have restocked on Pop-Tarts. We got about 20 different flavors now. Oh, I just grabbed the ones that didn't look like trash. Although someone is going to experiment with the box of chocolatey chorizo.
Wait,
Ever had chorizo?
what's that? Is that like meat?
It's like Mexican donut stick.
Churro.
Did I say churro or chorizo? Okay, chorizo is like meat.
I was gonna say
Sugared meat stick. No. Like, no. Churro, not chorizo.
that's why everyone's like, what?
Although a Pop-Tart that was like part sprinkled brown sugar plus sausage. That's like, don't make that. It's like, y'all never had just like pancakes and sausage and pour some syrup on there?
Yeah, but
Same. Oh yeah, Pop-Tarts are horrible for you. Okay, so I think we should have the limit of my, that's a g of x. Limit of g of x as x approaches negative infinity is limit of my function as x approaches positive infinity is. Okay, this is just how they're going to look. You state two limits. The limit as I go all the way to the left is negative infinity. The limit as I go all the way to the right, positive infinity. I mean, you know you grew up poor and getting everything from Kmart and the dollar store when you don't call it cherry Kool-Aid, you say, I want the red stuff. What kind of Kool-Aid is that? Purple? Okay, and positive infinity, negative infinity here? That's it. I mean, instead of writing them as coordinates, we're just, now we know what a limit looks like. Okay? Now, those are n behaviors that go all the way to plus n minus infinity. That's a specific value. Oh, they don't give us the chart. Okay, I'm going to give you the chart because it sounds like we don't remember the chart. Oh, wait, those are specifically for polynomials. We're going to do the n behavior test in the polynomial section. Never mind. Ignore me. Well, like, ignore what I said, not ignore me now. Do this. Graphs that approach a specific value. Sometimes the n behavior isn't positive or negative infinity. Sometimes it approaches a very specific number. Do exactly what we just did. Like, this kind of looks weird, right? I'm not sure if that levels off around 1. Does it keep going down? I'm not really sure what it does. Jam that into your calculator. Do that spam 9s trick and hit enter. And tell me, where is this thing headed? See if you can beat Laggy Frank. Okay. X divided by x squared minus 2x 8. And negative. Okay, I'm betting that none of you are into the original NES Tetris speedrunning circuit. I saw an article the other day, like 35 years later, someone developed a new button smashing technique, and they are starting to break all the world records for Tetris. Like 35 years later, someone figured out if I twitch my hand this way, it goes faster. Eh. But anyway, I have 1 times 10 to the negative 14th. What is that? Really, 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 really small. That's a positive 0.13 zeros 1. That's impressive. Normally, those will just keep doing scientific.
No,
Like,
it just went error.
huh?
I did 91. I don't know. I just kept pressing 9.
How fast are your friggin' thumbs? 91 nines? Okay, so this is really, 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 really close to 0, but positive. This is really, really close to 0, but negative, but they're really, really close to 0, right? So I can say that the limit of my function as x approaches infinity is 0, and as x approaches negative infinity is also 0. You can approach a specific number. We'll see that more when we hit the rational functions in chapter 2. Normally you have to go to factorials to do that. Now, y'all know the little spinning yellow circle up there, right? If you ever make that circle turn white, you broke it. Like you froze the calculator. Yeah. If you can do an overflow error on a graphing calculator, that's pretty impressive. So, I'll let y'all know I'm a pragmatist. Yeah, these are the two different end behaviors, but since they both went to the same thing, I'm perfectly fine with you saying the limit of the function as x approaches plus or minus infinity is 0, since they went to the same thing. Just save yourself a little bit of writing, a little bit of space. I'm okay with that. So, sometimes they ascend to a very specific value. Go! Find their limits. Find the end behaviors stated as limits. Again. Well, that's a name.
It's gonna be like a really weird test. Do you have like
I mean, I have toddlers. I should have one. But, oh yeah, these are my old swear jars.
for you?
Yeah, for me.
Oh. What did you have to do for the dog?
Yeah.
What did you do for the dog?
I would have to buy that class food when I hit a certain threshold.
We should do that again.
I had to institute something when my youngest was like 5, 6, 7 months old, because 3 hours of sleep a night consistently made my filter really bad. So, there you go. A legacy of an elder time.
That's a weird pickup. It's a solo phone.
It's a square base, so it's less likely to fall over. I love that you said that that's a weird cup, because that means that you're still slightly innocent. So,
Oh.
So in both cases, as I go to both plus and minus infinity, where's this one headed? 3. Now, I know it doesn't look like it because one has kind of a slower descent to it on this side, but this one, they do both go to the same place. Oh, wait. Limit of my function as x approaches both plus and minus infinity is -3. So, just dump it in your calculator, spam 9s. Okay. And the reason we need to know it from the table is because you can't always just see it on the screen. Like, what if this one went to -3, but this one went to negative, I don't know, like 20/21. Or wait, 3 and 20/21. What? Not that. Yes. No. It is ravioli because it's pressed on all edges, whereas a calzone is folded and only pressed on one. Lars, are you looking at the D&D sandwich alignment chart?
No.
Okay.
I'm just curious. Is cereal soup?
Don't start this again.
Yes.
Well, once anything becomes specifically defined enough, it is its own category. Like, there's a difference between I'm in a math class versus I was in Sullivan's math class. Right? So, oh, it's not specifically in here, but I want to talk about it. Go all the way back to the first page of section 1.3. And down here, when we first talked about limits, I would like you to argue out with your neighbors, what is the end behavior of this function? Go. What is the end behavior of this function? How do you write the end behavior as limits? Argue it out. I want to see what you come up with. I love the amount of, but wait, that I'm hearing. That's good. Argue it. Reason it through. As x approaches, meh, the limit is bleh. What do you think?
Die.
And then it dies. Okay, Grug. I still haven't seen Crudes 2.
I really want to.
It's okay.
Ruth was also good.
We should watch Crudes.
Crudes was on our, like, 8 to 15 times a week watch list for about a year.
I saw that
Yeah.
in the theater with my dad. And then when the dad
I identify with Grug. Like,
he's like, what? I'm dying.
so, I'm betting that everyone's cool with this part. But we started arguing about that other side. And that's good because Entire textbook publishers argue about what this is. Some textbooks, including ours, will say the limit of the function as x approaches negative infinity does not exist because the x's never approach negative infinity. So if it never approaches that value, it doesn't exist. The way that I was taught, the way that most other books I've seen, and I talked to Mr. Spear years ago when I picked up PreCalc to double check with him that he does this for calculus, is we instead say the limit of the function as x approaches -8 from the right. So we say a little like subscript plus on there. -8 from the right is -10. Okay. As we approach -8 from the right. Okay. Both of these are equally correct. But sometimes the domain does not go -infinity to +infinity. Like, what happens when we bring back our old logarithm graphs from Algebra 2? I want to, too bad. Okay, what happens when I have y is log base 2 of x plus 1? Okay, the limit as I approach infinity is still infinity, right? It goes off into the wild blue yonder forever. But our textbook may say the limit as x approaches -infinity is -infinity, or does not exist, because I can't, third rule of domain, thou shalt not take log of non-positives. So this does not exist from -1 back. So our philosophy was to say, as it approaches -1 from the right, it goes to -infinity. Okay? So as I come at -1 from this side, because I can't come at it from that side, the y's go to -infinity. Okay? So that is a distinction that I got to make that is not in the examples in this book. Just in case we run across it. I wanted to say there's like one in the homework like that. Just had to be careful. All right, applying end behavior. This is more like common sense. Gravitational potential energy, given by ugly formula. G is Newton's gravitational constant. M is mass of the object. M sub E is mass of the Earth. Is anyone in physics right now? Okay. Yeah, pre-calc and physics at the same time, you are going to see two very different philosophies. In that I am adamant we will do simplified terms of pi, i.e. fractions and radicals. Okay? You were all in at least Algebra 2 with me, so you know this. You write the real answer. Gabe likes to round his answers as he's working. Like, he'll round it in step 1, get thing, round it again in step 2, get thing, round it again in step 3, and by the end, it's a train wreck of not accurate. And I've had students who were in my classes and then went and did physics come back and say, I argued with him and he got mad. So just be aware of that. Be aware of that. Oh no! No! Okay. Like, everyone gets to do their own thing. That's fine. But, no. All right, gravitational potential energy, blah, blah, blah. Here's a formula. I'm going to plug stuff into it. Okay. What happens to the potential energy of the object as it moves farther and farther from Earth? Think about this in common sense. Gravitational potential energy, or weight, of a thing changes based on how far away it is from Earth. You all know that weight actually changes depending on your elevation.
Wait, does it really?
Yes, weight is the measure of gravity's impact on you. Mass is how big something is, how much matter is there.
So if I was to go up, what would happen?
You're further away from the center of the Earth, you are further away from the mass that is pulling at you, so its effect would be less.
So I'd be lighter.
Yes.
Oh, I can't say that.
Not a lot.
So if
Not a lot.
So if an obese kid with dietary issues.
It's not a lot. Like, it really isn't a lot. Do y'all remember the Travelocity commercials? The little gnome?
Oh yeah.
You too young for that? Like,
Oh, I remember.
the little gnome, he's like, I'm on my way! And then, like, throw the gnome across the screen or something, right? Someone actually took this gnome because I think so. Like, it was a publicity stunt from Travelocity. They took the gnome because the gnome has a very specific mass. And then they brought him around for all these different location shoots in Death Valley, at one of the base camps of Mount Everest, and they weighed the gnome because it's the same object. And they were able to definitively prove, yes, it weighs different. Now, it was like the difference of like 1.2 ounces because the Earth is kind of big. But, I mean, it really did. So what happens when I take that same gnome and I can and chuck him out into space? What is his weight going to do the further he gets away from Earth? Less and less and less, right? But I can prove that mathematically. G is a constant. It says G is Newton's gravitational constant. So I'm going to say U of R is negative number. Some number, doesn't matter. Just use common sense here. M is the mass of the object. Will the mass of the object change as it gets cannon shot out in space? No. I'm launching it into space. It's not rocket fuel. Y'all know that's why rockets go in booster stages, right? It dumps out all the fuel from the bottom stage of the rocket. Well, I don't want to drag around all this dead weight, so that part falls off, so I have less mass. So it fires the next stage of the rocket. Okay? So, the mass of the object doesn't change, so that's just a number. M sub E, mass of the Earth. I'm pretty sure mass of the Earth isn't changing. I mean, you can argue about at any given point. You've got, like, meteorites striking it, and
I have a really weird question.
Hi.
When you're driving, does your gas get hot?
It shouldn't.
So it just stays the same temperature.
It shouldn't, because the gas tank is supposed to be as far away from possible from a heat source. Like, it's a safety design feature. Like, if you put your gas tank on the same side of the vehicle as your catalytic converter, boom.
So if you were driving your car up Mount Everest super, super, super fast, could you technically catch air? Like,
what are we talking about?
No, like,
I zoned out.
I'm trying to explain my mind right now.
Watch Mythbusters, Google, go onto YouTube, Mythbusters rocket car. It'll tell you everything you need to know. Okay? And R is the radius. The radius is actually changing. So here's the deal. A number times a number times a number is just a number. It's some constant. That means that this, even after I plug in all these gigantic numbers, this is just a vertical stretch of the function y equals -1 over x. It's a really big vertical stretch of it because the number on the top is really, 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 really big, mass of Earth. But what happens when you take a really big number and you keep dividing it by something that's getting larger? What's eventually going to happen as limit of, not the function, u of r as r approaches infinity, right? If I take this graph and I go out to infinity, what does it do? Get really, 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 really close to what? 0. They're showing you that even in these formulas where you got all of these other variables all over the place, it all boils down to, do you know what this one does? Cool, it's going to do the same thing, just a little slower because the number on top's bigger. That's it. What happens to the gravitational potential energy of the object as it moves farther and farther from Earth? It will approach 0. Now, it'll never be pure 0. Technically, there is an asteroid on the other side of the galaxy that is pulling on us right now. But its impact is so infinitesimally small, it might as well be 0. That's why we say it approaches 0. The limit as I approach infinity is 0. Because technically, right now, Aubrey is yanking Colby towards her. We all have gravitational attraction. Like, matter does that. That's how planets are formed. A bunch of dust floating around. Eventually, dust got to dust. More mass. More dust. More dust. And eventually it coalesces into planet. Okay? So, do the same thing. Plug in what is a constant. What is a number that I know will just be a number? Rearrange the equation so that it's number variable. Okay, what does this thing do as I go off to infinity? This is just, do you know how basic functions operate? Oh, not in 0, infinity. Okay, it says you know the pressure, right? Dynamic pressure generated by the velocity of moving liquid is blah, blah, blah. Density of the fluid and V is the velocity. So, y'all ever done the bucket of water thing? Like, fill up an ice cream bucket of water and just keep whipping it around. It doesn't fall out, does it? Well, you've all either in now or have been in chemistry. You ever played with centrifuge? Okay, you put little test tubes in there and whoo, around it goes. Okay, the reason it does that is because it separates the different densities of fluid. The more dense stuff will fling out to the outside. Has anyone ever left a drink or cereal or some sort of liquid concoction, just let it sit there for too long, and you see like a bottle of ketchup? You notice how it sinks down a little bit, and at the top there's that little like puddle of kind of vinegar or whatever. You do that with peanut butter. If you let peanut butter just sit there too long, it's got that little bit of moisture in there. Density of the fluid, this is called cross-curricular topics. Density of the fluid, the more dense it is, the more effect gravity will have on it. It will pull it down. That's what that centrifuge does. It spins it really fast to simulate that in a sped up amount of time. So all the dense stuff goes to the bottom of the test tube and all the liquid stuff goes to the top. This is how you get concentrated forms of things. They're saying, what happens if it was like the Hulk being able to whip his arm around like that? Instead, what happens as the velocity keeps increasing? What's going to happen to the pressure? Infinitely increase. Because this is just a number. This is a really fancy version of number x squared. Well, that's just a parabola. What happens to a parabola as you go to infinity? Also to infinity. Okay. There's something to be said there for a corollary to high school activities. As you increase the velocity, so will the pressure. How many of you are doing way too much in your junior or senior year? You feel like you're already getting burnt out. It's like week 3. It was a couple of years ago. I don't know if any of you remember Morrill, Coach Morrill. Week 3, are we on 4? Oh. There's a couple of years ago, the whole back row was full of 8 volleyball girls, first period PreCalc. And they happened to have a AP History, PreCalc, Chemistry, tests, all on the same day. And they had a 6 a.m. practice. No, it was 5:30 as punishment for playing so poorly the night before. Apparently, the entire volleyball team started crying in practice. Like, one kid just missed the ball and then started bawling, which set off the entire team. Increased pressure is bad. Okay? Yep. And Morrill was very aggressive person too. So she just turned to work and said, "You deal with this. This ain't my thing," and just kind of left. She was hilarious, but that was not her scene. She's not the emotional, caring type. All right, I think we got that. Whatever. Cool. Extrema. Y'all know what intervals of increase and decrease are because they're pretty freaking obvious. An interval of increase says as my x's go from my lower boundary to my upper boundary, as my x's go lower to upper boundary, my y's increase. Duh. Okay? It literally says what it is. An interval of increase is as my x's are increasing, so are my y's. Interval of decrease, as my x's are increasing, my y's are decreasing. Maybe you remember this from all the way back in Algebra 1 in terms of correlation. Y'all remember positive correlation? Negative correlation? Positive and negative correlation says as my x's increase, my y's do what? In this case, as my x's increase, my y's increase. This would be a positive correlation. I would also, in terms of a function, call it an interval of increase. Okay? So think about real world things. As this increases, this also increases. Okay? The amount of time that you work, the amount of money you earn. Yes. Is it always fair? No. But the more you work, the more money you'll get. Now, not compared to other jobs, but in your specific situation, yes. The more children I have, the more I weigh, because they don't let me sleep and I stress eat. Okay? What's something that has decrease? As x's increase, y's decrease. Real world correlation.
Oh, as the homework increases, my mental health decreases.
Facts. As homework increases, mental health decreases. Okay? Oh, speaking of, are we distraction free? Are we still hitting that like 15 to 20 minute mark? Distraction free. Okay? All right.
Yeah, it depends on what we do.
Because if we're having 30 plus, someone needs to talk to me. Okay? Minutes of homework. Distraction free. Yes.
Oh, not in the other classes, yes.
Okay? So, intervals of increase, decrease, and... All right, dial it back in. Constant. Doesn't matter what x's are doing. Y is just this value. Okay? So if I'm going to state those as intervals of increase and decrease, I want you to read those instructions and see if you can predict what I'm going to say about those instructions. Support answers numerically. What do you think they want you to make again? Boo! We're not going to do a table, okay? They literally want you to have a table that shows as your x's go from here to here, the y's are decreasing. Y'all. Okay? So don't do that part, the support numerically, never do that. Instead, I can still... Frank, you some... I didn't say anything. If we're going to go off of what I thought, there's like an angry little redheaded dwarf with an axe who's running laps in my head going all day long. Okay? you cannot go by what we think. So, as I go left to right, as I go left to right, from negative infinity to positive infinity along my x's, I'm saying where my y's are increasing, decreasing, or constant. Now, this is one that actually tends to trip kids up because they think this little kink in the middle here means that it stops. That is not true. My interval of increase on this, well, it never does. My interval of decrease on this is all real numbers. But I do have to say it as an interval because we're talking about intervals. Don't just use the real number symbol. And then constant also nothing. This has its own special name. It's called a point of inflection. And it's when the rate of increase or decrease changes. When the rate changes. It's still decreasing, but the rate changed. So, give you an example. Let's say that I move the origin down here. Let's say this was an L graph instead. X, time. Y, speed of my vehicle. This is me coming in from North 85, getting over the overpass. It is now a 45-mile-an-hour speed limit. I need to slow down. I should slow down because I see a vehicle in the median. Oh wait, that's just one of the city trucks or something. So I'm going to let off the brake. But then I realize, oh no, it's just the unmarked cop. I should slow down more. Okay? I let off the brake. I didn't touch the gas, did I? I'm still slowing down, but I'm not slowing down as quickly as I was. So there's a change in the rate of my deceleration. And then I realized, no, that's just the unmarked cop. I better actually slow down. Okay? That's a point of inflection. A point of inflection is neither constant nor increase or decrease. Okay? A point of inflection is just where the rate changes. Think of it as decision point. Are those legal in South Dakota? The fuzzbusters? We used to call them back in the 90s. It's an infrared and radar detector.
Something else, as long as they're not a felon or something else, you can use them.
Okay. Because I know North Dakota, I grew up in North Dakota, and my mom had one forever because, like 55 miles an hour, okay. As long as that little light isn't pinging, that you know there's not a cop in the area, she just. Okay. Yeah. Being the math teacher, I actually sometimes out of boredom do the unit analysis calculations of my speed as I'm driving. And when I discovered that the difference between going on a 65 mile an hour road, 69 miles an hour versus 74, y'all know the 5 mile cushion, right?
Yeah.
The difference between them was literally a minute and 12 seconds. Like, that's not worth it. So I just don't speed much.
How did you get into teaching math?
I've wanted to teach since I was 12.
What, like why? What was
It was the only thing that I felt validation for. I was the angry behavioral child. I was in principal's office before kindergarten, or before lunch, the first day of kindergarten.
Oh, that sucks.
Yeah,
How did you do that?
Jen tripped me, so I threw her into that coat rack that's nailed on the wall. Well, yeah, this was, okay, my 8th grade graduating class was 12 kids. Like, Jen and I ended up dating like 5 times, okay, right? In a small town, that's how that works, okay? But, you know, I would push her, she would punch me in the kidneys. It was a love-hate thing, right? But Mrs. Ward, my 4th grade teacher, I ran over every teacher before that. They would cut the top and bottom of a refrigerator box and put it around my desk.
Were they actually?
Yes. I was on a first name basis with the principal. I was kicked out of school so much that my mom almost quit her job because of how often she had to come pick me up. There were problems, and I get to 4th grade. Mrs. Ward. You can't do that. Looks like I can. And she was my nemesis. She was my enemy. And I was always looking for a way to rattle her. And then she says, why don't you use those smarts for something good? Why don't you go help her? I helped her and I felt validation. Someone gave a rip about what I had to say.
And the music was playing. It's like
Okay. So.
Wait, did you help Jen?
Yeah. No, I was. I was the dude that everyone came to for answers. So. By the time I was 12, I was just the class tutor. So I've just always wanted to teach. Yeah, Miss Ward was awesome. She's great. What?
Did you ever charge people for your answers?
I should have. But I was unidentified autistic and I just wanted girls to talk to me.
Oh.
So anyway, math. Stop that. No. Bad Maddie.
No, if you're gonna do anything, do it for money. If you're already gonna do it, charge.
Honestly, that's what I did.
Revert back to our discussion of how you're getting $60 an hour. So.
It was $30 every time. Okay. For February.
These are the points where this goes from increase to decrease. Would you agree? It's going up the hill, goes down the hill. Okay? Those are called extrema. Extrema are the points at which increase changes to decrease or decrease changes to increase. I would say that this function is increasing. Okay, we were way off topic there. Maddie's fault. Bring it back. It increases from negative infinity all the way until what? No. X's. As x's go from negative infinity to what? My y's are going up. Negative. My y's are increasing. Okay? As x's are doing this, my y's are increasing. And then it decreases from -1 to where? +1. Don't say -2. As my x's go from -1 to 1, my function is decreasing. I suggest that you put that little arrow, that little line, and go across this way to remind yourself. Because your intervals of increase and decrease, you should be able to line them up as a number line when you're done. Okay? And then it starts increasing again from 1 to infinity. So, union. From 1 to infinity. Okay, say if I take this part here and I move it over. Do you see how this is a number line? Negative infinity to 1, -1 to 1 to infinity. As x's do this, my y's are increasing or decreasing. Okay? Why did I always use parentheses? At a specific point, look at the title of this example. It is intervals of increase and decrease. Just like when we had or 6, We didn't say bracket 6 bracket, right? So at a point, I am neither increasing nor decreasing. I want you to think about this like maybe your speed as you go through town and you start hitting stoplights. Okay? You all know you get past the hospital, there's not a stoplight for a while. So you're like, yeah, oh, I better slow down. It looks like it's going to be red. So I better slow down. I better slow down. Wait, no, go to the other lane because it just turned green. And you just zip around that old grandpa that's sitting there just starting to go. Right? So at that moment that you take your foot off the gas to move over to the brake, at that very moment, are you increasing or decreasing? Neither, because it's a specific moment. Increase and decrease literally depends on time. Like acceleration, by its definitive format, the formula for acceleration involves change in time. If your time is not changing, if you're at a single point, acceleration doesn't exist. Okay? Again, physics. So.
Why don't you teach physics?
Because I need 2 more classes to get my science certification. Go! Not really. For me, science, I realized I liked science because of the math. To me, science is just math for kids who never got out of the eating glue phase. So.
Are you calling Mr. Avery weird?
He seems more like a light things on fire. I was an only child on a farm like 15 miles from any of my friends. I burned a lot of things. See, I lived in that magical era where the internet existed, but 9/11 hadn't happened yet. So you could Google things like how to make pipe bombs and the FBI wouldn't come after you.
Well, do you remember how?
It was freaking hysterical.
Yeah. It's a lot more easy to do back.
Yep. It really was. It still is. It's just now you might be flagged for something. Both of them. That's why they're both highlighted. Intervals of increase, decrease, or constant. First one. As I go left to right, my pen is headed down until I hit 2. Don't say -3. As my x's go from -infinity to 2, it is decreasing. And then from that 2 onward, it is increasing. But it never is constant. Okay? Increase, decrease, and constant. As my x's increase, my y's are increasing as well from negative infinity. Now the instructions at the top say estimate to the nearest 0.5. I can get more accurate on this because where does it shift? Because that's the change in the. That's supposed to be a negative. That's a typo. Yeah, that's a typo. It specifically says at negative 3.1 is where it shifts from one rule to the other. So I'm going to say from negative infinity to negative 3.1, it's increasing, it never decreases, and then it's constant from 3.1 onward. Okay? Y'all, these intervals of, what? See?
You get to eat the brownies, Susan.
Yeah. Okay. This whole increase, decrease constant is along which x's is y doing that. Okay? Along which x's are my y's increasing or decreasing? It's really common for kids to kind of goof because they see this arrow pointing down and to the left. It makes some kids go cross-eyed. Okay? Just be careful with it. As the x's are doing this, the y's are increasing, decreasing, or constant. The reason so many of these things are dependent upon x, the independent variable, is because it's the thing that we change. It's the thing we have control of. I'm going to define my mathematics based on what I can change, what I have control of. Okay, Extrema. I bet you remember from Algebra 2 the difference between relative and maximum extrema. Just listen to the words, listen to the English. Why is this a relative maximum, but this is an absolute maximum? This is the maximum for this area. It is a point at which I transition from increase to decrease, but it isn't the maximum for the entire function. This is the maximum for the entire function. No y value for the rest of the function from negative infinity to positive infinity along its entire domain will ever get bigger than this. Difference between relative and absolute. You're teenagers. You constantly compare yourselves to each other. Social status. Well, you're a popular kid. Compared to who? Okay. Well, you're smart. You met my sister. Okay. Things like that in terms of comparison. A relative maximum is the maximum for that area in comparison to its surroundings. An absolute maximum, that's the king of the hill. Okay? Same thing goes for minimums, relative and absolute. They have over here, oh hey, extrema and point of inflection. I always forget that's there. Extrema, we already said that's where it changes from increase to decrease, or vice versa. And point of inflection is where the rate of increase or decrease changes. So we already said those, just oops. And they got a primary example of it right there. The difference between a maximum, a minimum, and a point of inflection. Don't try to say that it's constant at the point of inflection. It's still decreasing. It's just the rate change. It gets that little kink in it. Okay? Now, if you're able to zoom way in on this, and you see that it does this, you see how there's just a tiny little bit of rise to it? Okay, now there is actually a relative maximum minimum there. But you'd have to zoom way the crap in on it, and that's probably not the case. So just be careful with those. If you're ever not sure, zoom in on it. Okay. Oh, I got a thing there. Yeah, we only got 3 minutes left. We'll come back to this later. Okay, we'll cut it off there. The homework is just the back half of 1.3. All right. We'll probably just do all of 1.4 tomorrow. I don't know if we'll move into 1.5 or not. Probably not. Probably not, because I don't want to start a 2-day lesson right before a weekend. So we'll just finish 1.4 tomorrow and call it quits.
Been overlooked, I think, tragically for years by psychology as a science, but it's one that has been intuitively understood by writers, by artists, by mathematicians, and many, many others. So there's a really easy way to show this, and that's to invite people to come to your laboratory and give them what's known as a divergent uses task. So this is a test of creativity where you're handed common household objects, and your job is to come up with as many alternative uses for that object as you possibly can. And people